Hello everyone, we are the students of IIT Bombay from the Introduction to Flight course. So we are here to participate in a competition of glider. So our target is to achieve the maximum range and the maximum endurance. This is Team 6 building 2 gliders. For maximum range, the glider is supposed to be launched from the middle of the foyer and should hit the middle of the glass wall before Shiru Cafe, or should go as straight as possible. If the aircraft lands away from the straight path, then appropriate penalty will be imposed. For maximum endurance, the glider should stay in air as long as possible. And for both cases, if glider touches the obstacles or the walls, then appropriate penalty would be imposed for us. We require a launcher to launch with less variability and to keep the parameters fixed, like the velocity and the launch angles. So there is a rail on this launcher. So to reduce the roll and while launching, the slip has to be reduced. That is why when we put the glider onto it will fix into the exact rail. And there are screws behind as the anchors to anchor the rubber band. We also use different kinds of materials instead of rubber band, like the rubber fabric and resistant bands. But then we realized that using the resistant bands didn't give us enough grip to launch the glider. And before we didn't introduce this block, but then we lately realized that when the rubber band is touching onto the glider is damaging. So we introduced the block to launch this glider.
We choose the styrofoam glider because theoretically speaking, the condition for the maximum range and maximum endurance will be different. We are glider are not sophisticated to change the CL value. That's why we choose the another approach. We decide to go for the lighter weight material that can with less velocity and sink rate will be less. So we made the styrofoam following this dimension. You can see by pausing the video. We drew the part of the styrofoam sheets and cut them. Then first problem encountered during the fabrication while joining this part with the Fevikwik and glue, it was the dissolving and styrofoam was damaged this part. Then we had to make the parts again, and we come with a solution, like we stick the tape where we want to stick that part, and upon that we use the glue gun.
The leading edge and the trailing edge were shaped by the cutter and the sandpapers by providing smooth flow to provide the smooth flow for the air for the wings. We also covered the leading part of the wing with the sellotape so that it increases the smoothness and also to protect the leading edge from preventing multiple crashes. The wings were made up of styrofoam. The fuselage and empennage were made up of balsa wood, giving it stiffness and strength. As we have seen in the video lectures, introduction to flight, we want to keep CG at the quarter chord of the wing for the maximum range and endurance of the glider. So once the glider was fabricated, we used skewers to balance it with the quarter chord of the wing, and the CG movement was controlled by putting some clay on the nose of the glider.
The flight was smooth when launched by hand, but was pitching up and stalling when launched using launcher. This was because we had given the incidence of 5 degree for the wings, and because of the shape of the glider, launching it with 0 degree angle was not possible. So we had to decrease the launcher extension length and the angle launch. Also, later we made a notch in front part of the fuselage for the same. As seen from the trial videos, the aircraft was banking to its left. So we saw a rudder deflection at a vertical tail by attaching a paper and folding it a bit towards the right, after which the aircraft started banking to its right. Also, we wanted our glider to make horizontal loops in the air, but observed that the turning radius of the aircraft was too large and it was hitting the wall. We also tried launching from the extreme left of the launching position to give it more room for turning, but the turn radius was too large for that also. After multiple launches and crashes, the wing dihedral, which was designed to be 4 degrees, changed for both wings. So we fixed the dihedral by sticking bent aluminum strips to give it stiffness. Fixing the dihedral angle, we did a flight test, and while attaching it in the mid-air, one of our teammates broke the horizontal tail of the aircraft. We did not have much balsa wood left, so we replaced it with the styrofoam.
Since making horizontal loops was looking impossible with this glider, we wanted to be as slow as possible in straight flight and do a VV motion to increase the flight time. When doing flight tests to complete this objective, it crashed again and one of the dihedral supports came off and horizontal tail broke off. This was just some hours ago from the competition, and we had to repair this again. After completing the when doing flight tests to complete this objective, it crashed again, and one of the diagonal supports came off and horizontal tail broke off. This was just some hours ago from the competition, and we had to repair this again. After completing the repair works, we achieved a maximum flight time around 8 to 9 seconds before landing, but still the aircraft wasn't going straight and banged on its left, and due to no less time left, we changed the launch direction for competition slightly towards right to maximize the time it stays in air, but even then it didn't perform as well.
So the choice for our glider was predominantly balsa wood. Why balsa wood? Because balsa wood is one of the very popular choices for making gliders because it has many advantages over other materials. One is it has a very high strength to weight ratio. It is strong despite being lighter in weight as compared to other wooden materials, and it provides a very good balance of strength and structural integrity also. This is the glider which we made from balsa wood. After building it, we balanced the CG using certain features, many features, like using clay at the nose of the glider. While conducting the flight test, it was observed that the aircraft was slightly banking towards the left. So we had to add some counter weight on the right side of the glider. We used a very thin metallic strip so that the aerodynamic shape is not disturbed. We wanted to keep this weight as less and streamlined as possible due to the sharp edge of the glider, which we named the glider as switchblade. After this modification, the glider had a slight tendency to roll towards the right, as seen from the flight trial videos. In one of the flight trials, we were successful in hitting the glass wall before the Shiru Cafe by missing the column. So it was a successful attempt of covering the maximum range. After many flight trials, the vertical tail of the glider broke and it was fixed again, but was slightly flimsy and flexible. To correct the right roll tendency of the glider, we included a rudder deflection by adding a small paper strip to the rudder to make the glider turn slightly towards the left and keeping it on course. After repairing the aircraft, we had another flight trial just hours before the competition. However, it suffered a major breakdown and the glider split into two, as can be seen here. After which we made some modifications. We added some reinforcement to the glider, but the performance of the glider was not as good as it was before. So we had to keep this glider as a standby.
We had to make this on a very short notice because our range glider switchblade had broken in testing, and we wanted to make this very small. Seeing other gliders, and also as small glider will reach the ground earlier than a heavier glider, and as we had less time, we wanted to make it very simple. So we got this design from internet and made it using styrofoam and using balsa wood to give it strength. Used clay to balance the CG at quarter point of the wing. We also had to shape the leading edge and trailing edge to ensure that the wing section behave like airfoils. First, we started launching this glider at large angle to maximize the range, but it was going on other side of the foyer instead of going to the door. Then we reduced by doing few trials. Once the launch angle was finalized, we conducted further trials and observed that it kept rolling on one side and had to balance it by adding weight on the other way. But after rigorous testing, the vertical tail had come off and had to be stuck again and it was exactly perpendicular to horizontal tail and wings due to which the aircraft started rolling again, and we didn't have much time to add rudder or tail deflection. So we estimated some change in the direction while launching to get the maximum straight range. Yeah, so we didn't win any of the categories and our performance in the competition was average, but we learned a lot of things like how to vary different parameters like CG, location to alter the glide performance, the impact of lateral weight distribution on roll performance. We saw other team gliders and one of them had detachable wings and empennage to minimize the damage in events of crash. That was a good idea. Also, Team 3's design for endurance was great, extremely lightweight, original design and stable, stayed in air like for approximately 16 seconds. Also by luck they didn't hit the pillar.